If you've ever looked at pictures of the planet Uranus, you might have noticed that it looks kind of sideways. Well, scientists think something big must have crashed into it in the past, but they can't agree on what. Some say it was another planet, maybe even bigger than Earth. Others say it was a huge icy shard from the formation of the solar system. And some say it wasn't an actual planet at all, just a really big space rock. But how did this impact explain not only Uranus's weird tilt, but also its rings and sideways orbiting moons? Welcome to my channel. This is Sideways Planet Smackdown. The first piece of the puzzle is, of course, Uranus itself. It's tilted over on its side relative to the Sun, around 90 degrees, and that is super weird. Most planets in the solar system rotate with a slight tilt, but they're all pretty close to having an axis that is perpendicular to the Sun. In other words, they spin on their sides, but they mostly spin up and down instead of side to side. Now, Uranus isn't spinning exactly on its side. It still has a slight tilt relative to its orbital axis. It's more like it got hit on its hip rather than directly on its top or bottom. But it's still enough of an angle to make Uranus a bit of an oddball. But the thing is, it's not just the planet that's sideways, so are the rings. They're intermediate in complexity, halfway between the more extensive set around Saturn and the simpler rings found around Jupiter and Neptune. A lot of the Uranian rings are opaque enough to cast shadows, and they span thousands of kilometers across, yet they're only tens of meters wide. They orbit around the planet in a plane that is also roughly perpendicular to the Sun. It's the same story with many of Uranus's known moons. Like its rings, they also orbit in nearly the same plane as each other, and they are also pretty much perpendicular to the Sun. Miranda, for example, orbits very close to the planet and has its own weird features like enormous cliffs, canyons, and faults. At first glance, it looks like a chunk of Uranus's crust broke off and fell into space. It's so jumbled that we can't even tell which way is up or down. So how does a whole bunch of stuff end up orbiting a planet in a weird sideways direction at the same time? The answer: something slammed into Uranus. But what? First, let's look at how an impact would affect a planet's rotation. When a planet forms, it starts out hot and gooey. Gravity pulls it into a roundish ball, and it spins quickly, partly because stuff is still flying around from the collapsing cloud of gas and dust that made it. Then, as it cools, it eventually solidifies, but by then, its rotation is already set. The further away you get from the center of a rotating object, the faster it spins. So, if you slam something into a planet, it will transfer some of its angular momentum to the planet and change its spin rate. And depending on where the collision happens, it can also change the tilt of the planet's rotational axis. That is, unless the thing that hits it is moving sideways. Imagine a bowling ball rolling horizontally toward a pin. If it hits the pin head-on, the pin goes down. But if the bowling ball is moving in exactly the opposite direction as the pin, nothing happens. That's because the collision is perfectly inelastic. They both keep rolling together without changing their overall motion. In space, if two objects collide in exactly the wrong way, they stick together and keep on going. Now, take two spinning spheres and smash them together sideways. The outer edges of the two objects move away from each other, and the inner parts move toward each other. As they approach each other, they speed up, and when they meet, they stick together and keep spinning. The final angular velocity of the combined sphere is somewhere in between the initial velocities of the two pre-collision spheres. This is called an inelastic collision. If the collision is head-on, then angular momentum is conserved. The angular momentum of an object is its mass times its velocity. The farther that mass is from the axis of rotation, the more angular momentum it has. And if the mass gets closer to the axis of rotation, it loses angular momentum. To put it simply, angular momentum is like a measure of how fast something is spinning. If there's no external force, it's always conserved. But in an inelastic collision, kinetic energy is not conserved, it's transferred to heat and sound. Okay, so let's try this thought experiment again with a planet instead of a bowling ball. If a planet strikes another planet dead-on, it will definitely knock it sideways a little. If the collision is glancing, they'll both keep spinning, but it could also make the second planet wobble a bit. But if the collision is completely sideways, the first planet won't change the second planet's motion at all. They could have been knocked sideways and gone on to become ice giants like Uranus and Neptune. After all, there are hints that Neptune is also a bit sideways, though not as dramatic as Uranus. Or maybe those two planets formed in the same way. We know that Neptune and Uranus have similar compositions and they're similar in size. Maybe they once made a pretty good team. Maybe they were once best friends. Anyway, that's probably not the real reason Uranus is on its side. Those impacts could have altered the rotations of the planets they hit, including Uranus. Well, actually, no, as long as the bolide didn't hit all three at once, that is. Those new rings and moons would inherit the planet's rotation, but they would also form in a thin disk. A bolide hitting the planet after its rings and moons formed is less likely, but it is possible. Basically, a giant space rock could have come in and messed everything up. For example, it could have knocked the moons into their current positions while they were still forming. Maybe, but here's the problem with all these scenarios. And if something like that slams into a planet, you'd expect to see some serious fallout. There would be a lot of ejected material, maybe even enough to form a thin dark cloud around the planet. And if it was once part of a wayward moon, there'd be a trail of debris leading away from the planet. But astronomers haven't seen anything like that around Uranus. We don't have images of the entire Uranian system from every angle, but we do have good views of its poles. If there was a giant crater or a dark cloud, we should have seen it. The gas would have trapped the debris and prevented it from escaping the solar system. Evidence for bolides in general is actually pretty sparse. Most of the time, it's only detected by radar. And this is the same issue with impacts to Earth. We only really know about them when they leave a visible scar on the crust, such as a meteorite crater. And a lot of bolides never make it to the surface. In fact, it's thought that Mars lost about half of its atmosphere because of impacts over time. But small rocky bodies called meteoroids aren't the only thing that can smash into Uranus. There's also a class of objects known as comets. If a comet big enough to leave a visible scar on Uranus struck it, its debris would spread out along its orbit. We do see rings around Jupiter and Neptune, which may have formed from comet impacts. What's more, most comets don't fly by very fast. Even the ones that come closer to the sun do and usually travel more than a few dozen kilometers per second. That's nowhere near fast enough to explain Uranus's sideways tilt. We've only visited it once with the Voyager 2 probe, and that was in 1986. It is hard to solve a mystery when the only time you've ever seen the crime scene was 37 years ago. Future missions will finally reveal the true nature of Uranus and its rings and moons. Maybe they'll find evidence for a giant impact, or maybe they'll find none at all. Thanks for watching this episode, which was brought to you with the help of our patrons. If you'd like to help us make more videos, you can get started at our support page.